Hey everybody, welcome to another problem session, and this time we're going to continue to work with IIT JEE 2023 Physics Advanced Physics Paper 1, and we're doing section 3, and the last 5 problems were from section 3, and this is the last problem from section 3, and this is called question 13, and it's also another simple problem. All right. So let's look at the problem. So here is the problem. So these are point-like objects, so you don't need to worry about when you do moment of inertia. You just treat them as all these masses at that point. Okay. The system is suspended vertically. So the master rod of length. The system is suspended vertically from a rigid ceiling using a thin wire attached to its center of mass. So this is not at the midpoint but at the center of mass. Okay, this point is center of mass of these two, and they are different masses, so this is not actually midway. The resulting torsional pendulum undergoes a small oscillation. The torsion constant of the wire is this. The angular frequency of the oscillation is this. The value of n is that. Okay, so you have to kind of know the torsion pendulum a little bit, right? So so if you have a torsion pendulum and whatever is kind of twisting, this wire is twisted, but it's not twisted very much, so energy of the twist angle is theta, so energy is half, let the moment inertia of this be I d theta dt square plus half kappa theta square. So this is a simple harmonic motion. So from this structure you can, this kappa is the torsion constant, so you can see that angular frequency of oscillations should be equal to, which is written as, say, omega, should be square root of kappa over I. So how do I know that right away? Well, you just compare that with half dx m dx dt square kinetic energy plus half kx square for a spring motion. This for a spring motion, and here omega is square root of this number over this number, k over m. So exactly this number over that number, except the I here has to be calculated. So if this is 30 gram and this is 20 gram, then this point being center of mass, so you have to figure out what this distance is and what this distance, because this is going in this circle and this is going in this circle. So you can find the center of mass. So I'm going to just work it out and to speed up the video. Okay, I decided to change my mind. I want to decide to show you how to find this point. So there are a couple of ways you can find. One is, of course, you can say 30 L1 equals to 20 L2, and L1 plus L2 equals to 10 centimeter. So cancelling that, L1 plus 3/2 L1 is 10. So L1 equals to 2/5 times 10, and that's 4 centimeter. And so the L2 equals to 6 centimeters. So that's one way. Another way is put an x-axis this way, put origin here. So how far away is the center of mass? This is the center of mass. So xcm, just use the definition, 30 plus 20, and 30 times 0, it's at the origin, plus 20 times it's at 10. So this gives you 20 times 10 over 50, and that's 4. So it's located at 4. So that's another way to get it. So once we have gotten this, we should be able to find moment of inertia. That's what will go into this formula. So moment of inertia will simply be m1 r1 square plus m2 r2 square, because this is point masses. So m1 is 30 and is going at 4 square, and this is 30 grams and centimeter square. So this is in grams centimeter square units. 20 is at 6 square. So this is 16 plus 36 times 720, and so 1200 gram centimeter square. And so let's look at K is given in Newton meter over radian square. So convert this into kilogram meter square. So to kilogram is 1.200 kilogram centimeter square. This one will add another 10 to the power minus 4 kilogram meter square. Alright, so now we have these values, and K is given 1.2 times 10 to the minus 8 Newton meter radian inverse, and I is 1.2 times 10 to the minus 4 kilogram meter square. So if you work this out the unit should in the end should be per second. You can forget the radian part, it's going to be per second. So the whole thing has become 10 to the power minus 2. If cancel out, take a square root, right, per second, and use a radian per second, but I'm going to just do radian. So you say why radian becomes this to above is because you're not supposed to use any of this unit radian, just per second. 10 to the minus 2, so 10 times 10 to the minus 3 per second. So this is the n that they're asking us. So the value of n is 10. Okay. Now let's look at what went into the calculation. One was that I had to find out or know that omega will be some kind of restorative force per se, inertial force, right? The restoration, and inertial. And if you know this ratio, whether it came from here, analogy with here, or you write down equation of motion in torque equals to I alpha, you write this equation to get that. Whichever way you get that, you have to know this. Another thing that was critical is to find the center of mass. You need to find the center of mass. And if you just have two bodies like this, it's really this is the preferred way of getting the center of mass. But even you don't do this way and you want to proceed with the x-axis, this is okay too. This is okay too. And then you have to do moment. And what I found really annoying in this problem was that I had to, the units were given so that I had to convert this because k was given in 1 unit and everything else was given another set of units, CGS unit and MKS unit. So this is just a not testing any conceptual thing, and because time is short in this test, I think this was a poorly made problem. All right, so far for section 4. Section 3. We will get to section 4 in the next video, and I think section 4 is has 4 problems, and this is kind of tricky. This is a set of problems which require some thought and some strategy to make it go faster. Okay, all right, so I'll see you in another video. Take care. Bye.